Before we start learning about conditionals, we need to introduce some operators. What symbols does MATLAB use, and what are conditions? You are very familiar with arithmetic operators: addition, subtraction, multiplication, division, exponent. There is one you have never ever used in the past, is the opposite division. If 6 divided by 2 is equal to 3, what is 6 the other division to? Well, it would be 2 divided by 6. It reads it from right to left. This is very unusual and specific to MATLAB. I have rarely used it ever, but it does exist. Relational operators, you are familiar with a couple of them. Less than or equal, greater than or equal. There are two more. Is equal to, with two equal signs glued together, and is not equal to. Not is the tilde, and an equal sign, again, glued together. When the operator is made up of two symbols, it has to be glued together. You cannot put a space in between. Brand new operators you might have never seen in the past. And, or, not. This is when we want to check if a number is greater than this and greater than that. Or if we want to check if a value is not another. First, let's review relational operators. It allows a program to compare how two values relate to each other. Two values and only two. For example, assume a variable var has a value. You do not know what it is, you don't even know its data type. Is the value in var greater than 3? This would assume that var is a double. We could write it as var greater than 3. But we could also look at it as var less than or equal to 3, which is its opposite. In either case, MATLAB would tell us true or false. Is the value in var less than or equal to 9.8? In this case, we can again look at it two different ways. But this also works for letters. Is the value in var not equal to q? In that case, var should be a char data type. Maybe you're asking the user to enter a q in order to quit, and you do need to check if it's not equal to q in order to continue. Var not equal to q. Keep in mind to use those quotes for letters. Or is the value in var equal to c? Maybe you offered a menu and you want to check if it's equal to c. In that case, you use two equal signs. These are conditions. We are comparing one variable to another. Whether it is a constant or another variable makes no difference. We are comparing two values. Let's spend a little more time on that equal sign. We have used equal in the past. A single equal sign means to assign a value, i.e. to give a value to. If I give you an assignment, meaning I give you stuff to do. If I assign a value to a variable, I give a value to a variable. There are a lot of ways to give a values. Gravity equals 9.81 is called hard coding. Perimeter equals 2 pi radius, you're using an equation. Acceleration equals input enter acceleration, you're prompting the user. But in all cases, we are using one equal sign. We want to give a value to a memory location. To check equality, though, we need to have two equal signs. We no longer want MATLAB to go in memory and shove that value in there. We actually want MATLAB to go get the value in memory and compare it to another. So we'll never actually type it alone, gravity equal 9.81. We will always put it in a conditional statement, which we'll see very soon. But in this case, I have an if. If the gravity is equal to 9.81, it is Earth. So I don't know what's in memory. Gravity exists, it's a location in memory, has a value. All I'm asking MATLAB is to go get that value and compare it to 9.81. results of condition. Now you have to understand that programs, all of them work the same way. They look at a condition and they make decisions based on their result. Is this true? Is this false? What do I do if it is? What if I do if it is not? Computers always come down to two values, 0 or 1. And programs know this. Whether it is MATLAB, C, Java, any program out there will understand zeros and ones. So they're very specific. 0 is equivalent to false. 1 is equivalent to true. When MATLAB evaluates a condition, notice the word evaluate, gives it a value. It returns a 0, 1. MATLAB will then know what to do based on those numbers. Let's see examples in MATLAB. Assume I have a variable called x, 3.3. And then assume that you forget about the variable x. You don't remember what it is, but you want to know if it's greater than 9. If MATLAB returns a 0, it means it's false. So x is not greater than 9. Well, that's true. If you remember, 3.3 is definitely not greater than 9. How about x less than or equal to 2? False. 3.3 is still not less than or equal to 2. How about less than or equal to 4? That's true. 3.3 is less than or equal to 4. So MATLAB knows all the chronological aspect behind the scenes. It also works with letters. Suppose I put a C in there and I forget about it. Is my letter equal to A? True or false? What do you think will show up? Answer equals 0. C is definitely not equal to A. Therefore, the answer is 0. Little trick question. How about this one? Still false. The smaller case is not equal to the uppercase. MATLAB also knows that behind the scenes, so it returned a false. Let's try it with a normal C. The answer is true. So MATLAB says this condition is true. You can also check inequality between letters. Somewhat unusual for engineers, but if you're doing an address book, perfect example. If you're trying to organize alphabetically, this is what MATLAB will use. A is less than C, which means that A comes first with respect to C. Now that we've seen a review of relational operators, let's move on to the last, Boolean operators. They allow us to combine conditions and look at the combined result. So we have multiple conditions, multiple relational operators, but now we want to combine them. We've got 3 symbols possible. 2 ampersand above the 7 key, 2 pipes above the enter key, and the tilde under the escape key. And or not. Maybe you want to check condition 1 and condition 2. Maybe you want to check condition 1 or condition 2. Maybe you want to check not, so the opposite of condition 1 or condition 2. We'll see example very soon. There are 2 rules to remember. An AND statement will return a true if all conditions are true. So if there's a single false in there, the whole deal is off. An OR statement will return true if one condition is true. So it doesn't matter what everything else is, if only one is true, the whole thing is true. The AND, the tilde, will negate a statement. It means that a true will become a false will become a true. Let's go quickly to examples. Is the variable strictly between 2 and 6? Even if we say it in English, we have the words 2 less than the variable and the variable less than 6. So we want to check two conditions. Maybe I want to check if an option is equal to A or C. Imagine a menu where you offered the options A, B, C, and you want to proceed if the option is equal to A or C. In that case, you would write option is equal to A or option is equal to C. In that case, only one of these conditions needs to be true to proceed. Maybe you want to check the opposite. Once again, you're offering a menu 1, 2, or 3, and the user enters a 4. You need to catch that. So if it is not 1, 2, or 3, in that case, it's the negate operator that might be used. Not in front. In parentheses, what you wanted. You wanted the option to be equal to 1, or 2, or 3. Note you could also distribute the tilde within the parentheses. In that case, you negate every single symbol that you see. Equal equals becomes not equal, or becomes and. Both are identical. They will return true in the same scenarios. Common error. We absolutely see this every time. Do not try to shortcut. Even when you say it in English, if you say it right, of course, you hear the word and or. In these two options below, you do not see these operators show up. It is wrong. You are trying to do var between 2 and 6, but that's mathematics right there. It is no longer programming. You might be trying to see if the option is equal to A is equal to C. Once again, it doesn't even make sense in English. You want to check if the option is equal to A or C. So you need that or operator somewhere. And in all cases, you need to rewrite the variable name for each condition. Here's a rule. If you see a relational operator, you need a variable in front. Quick example. Imagine you're trying to describe a quadrant system, a coordinate. Where am I on this plot? If I'm on the x-axis, y will be equal to 0. If I'm on the y-axis, x is equal to 0. If I'm on the top right, think about the condition x is greater than 0 and y is greater than 0. Notice I am not shortcutting anything. I have the condition x greater than 0 alone and y greater than 0 alone. Then I combine the two using the ampersands. If I'm in the top left, x is less than 0 and y is greater than 0. How about the bottom left? X is less than 0 and y is less than 0. I am always writing x first, but just so you know, you could flip both. You could do y less than 0 and x less than 0. Last, x is positive and y is negative. Now there's one particular point we haven't talked about yet, and that's the origin, where both x and y need to be equal to 0. So even to describe a coordinate system, I have 7 conditions to check. The key points before we move to full conditional examples are: operators are nothing but symbols. You are very familiar with the arithmetic ones. The relational operators compare 2 variables and 2 only, but it does create one condition. If you want to combine multiple conditions, then you start using Boolean, with the rules that apply to each one of them.